done that. Okay. Okay, so guys, let me just start with your today webinar. So I welcome everyone on this webinar. First of all, my name is Hemu. I am the like CCI security certified and Palo Alto certified, and I'm the trainer for this particular webinar. So basically today what we will do, we will focus on, we have in Palo Alto Firewall, we have some utilities, or we can say some troubleshooting utilities, which generally we will use for connectivity related troubleshooting. Basically, we are not discussing any kind of feature troubleshooting like your VPN is not working, not like that. I am just focusing, let's suppose if you are accessing any of the server, right, and you are not able to access it. Now how you will troubleshoot that thing, how you can see where on your Palo Alto firewall this particular packet is dropped. So the main agenda for this particular webinar is, first I'll just go with the global counters, because guys, with the help of these global counters, we are able to identify around 90% problems. Basically, your packet is blocked by the security policy, or your packet dropped due to the routing, due to net, right? What was the reason? So we can basically, first I will discuss what are the global counters we are having on Palo Alto. Once I will done with that, I will discuss packet filter, means how we can create a specific filter on the basis of source IP, destination IP, source port, destination port, protocol number, application, right? And after that, how we can take the capture. We are receiving the packet on Palo Alto firewall. Now how we can take the captures and how we can analyze the packets. Once I will done with that, I'll basically cover your flow basic, where we will see how Palo Alto firewall process the packet. Basically, what are the different stages we are having on Palo Alto firewall, basically. So I will cover all of them. So let's see, because generally for that I need around a minimum 3 hours of time, but let's see, I will try to bind up all these things in 2.5 hours, but let's see how we can complete. So before going into these utilities, guys, let me just explain you some architecture of your Palo Alto firewall. Okay, so if I say, if I design the data path of your Palo Alto firewall, that I think if you have taken some trainings from me, you already aware about that, but let me just go through with that. So first we will discuss the data path of your Palo Alto firewall. So in your Palo Alto firewall, generally what we have, these interfaces first. So here, let me just draw the interfaces stack. This is your interfaces stack. Let's say we are having interface starting from Ethernet 1x1, 1x2, 1x3, 1x4, 1x5, 1x6, and 1x7. Let's say we are having these 7 interfaces on your Palo Alto firewall. Now, these interfaces, they have a directly connectivity with one of the chip in your Palo Alto firewall. That chip is known as Marvel chip. All these interfaces, they have a connectivity like this with your Marvel chip. Now, this Marvel chip, it has a further, that chip is connected with one more chip on your Palo Alto firewall. These are the internal component, guys. Okay, so that chip name is, either we can say Liga in low end boxes, and we will see another chip in the high end boxes. So if you are having like data center related data center level firewall, like 5200 series boxes, or 5000 series boxes, 7000 series boxes, you will get the Tiger chip, right? If you have a 3000 series box, you will get the Liger chip there, right? That chip is also known as network processor, or in your Palo Alto firewall, this network processor is also known as session offloader. And this Marvel chip, it has a connectivity directly with this particular Tiger and Liger chip. Now, after this, basically, This Tiger or Liger chip or your network processor, it has a further connectivity with one of the chip here. That chip is known as Octeon chip. So now this Octeon chip basically is also known as your data plane CPU. This is your data plane CPU, guys. Now this Octeon chip, it has a further connectivity with one more chip in your Palo Alto firewall. So let me just draw it properly here. Now that chip is known as your Jaguar chip. Now why I have basically I'm explaining these chips, because now if I'll say this is my, let me just go like that. Let me draw one more diagram here. Let's suppose this is my Palo Alto firewall. This is the one of the PC I'm having, or you can say this is your test machine. This firewall have a connectivity with, let's say, one more server on DMZ or maybe outside. Okay, this is your server. Let's take an example. This interface Ethernet 1x2 and this one is Ethernet 1x3. Now, let's suppose this PC having IP address 10.1.1.70 and that server having IP address 10.2.2.101. Now, if this PC wants to access any of the service on this server, let's suppose we are hosting web services on this server. So everyone know web services hosted on TCP port 80, right? So from this PC, when we want to access this server, right? And when we send the first packet from this PC towards the firewall, always this first packet is a TCP SYN request, because or your web service, they runs on TCP, right? So first, in case of TCP, they will go through with the TCP three-way handshake. Now, when this firewall he received this first packet, now your firewall will start processing this packet, guys. So how it will start processing the packet? Let's take an example. The same packet we have received on this interface. So this packet now reached to your Marvel chip. Marvel chip will forward this packet to Tiger or Liger chip, and this chip will forward that packet to your data plane CPU. So why I have explained this architecture, guys? Because in Palo Alto firewall, we are having some kind of packet processing, or we have some life of a packet stages. So let me just write down these stages. The first stage is your ingress stage. Then we have your flow lookup. Then we have third one is your slow path. This slow path is also known as session setup stage. The fourth one is your first path. Then we have your fifth one is your app ID, where your application identification happens. Then sixth one we have your content ID, where your all your thread signatures available for URL filtering, right? All these tasks done by the content engine only. Your antivirus protection, your anti-spyware protection, your vulnerability protection, your file policies, everything is a part of your content engine, right? And the seventh one or last one is your egress stage. So these are the packet processing stage we have in your Palo Alto firewall. Now, so if you will see, out of these 7 stages, your data plane CPU, what it will do? It data plane CPU or your Octeon chip is responsible for your ingress stage, your flow lookup, your slow path activities, and your fast path activities, and your egress stage. So these 5 things basically your Palo Alto firewall do with the help of your data plane CPU or with the help of your Octeon chip. Your app ID and content ID is done by the Jaguar chip. This is your app ID and your content ID. These two activities done by this particular chip. And these are the guys dedicated FPGA, I can say. Field Programmable Gateway Array. Okay, these are the ASIC, we can say, or chip inside your Palo Alto box. Now, if you know this architecture, so when you will take the capture, guys, right? Or let's suppose we are, or let's suppose your packet is dropped at the ingress level, or if your packet is dropped at the flow lookup level, or your packet is dropped at slow path or fast path or at egress stage, where we will check these packets thing. These information we have to check inside the Octeon chip, guys, right? Or we have to take the capture, so we have to look the information at the data plane CPU level, right? Now, if something is dropping due to the application or content identification, then where we have to check that information, we have to check the information on your Jaguar chip, guys, right? So now, why I have just bring this thing for in your attention, because if I'll go here, so now guys, I'm just starting your counters in your Palo Alto Firewall. So if you will go here and if you run this command, so counter global, and you will get here lots of counters, guys. See, here we are only able to see these very less counters, but in actual, in Palo Alto Firewall, you will see 256 plus counters, guys. We have around 256 plus counters, and for each task, basically, these counters, if you will see, they have some kind of values, right? So what, whenever any of these things will hit, let's suppose we have received the packet on your Palo Alto Firewall, right? You will see the value will increase for packet receive counter, guys. If Palo Alto is sending any packet, you will see the value of this counter will increase. Let's suppose your session is allocated or your session is installed in your session table or in your flow table, right? That time this counter value will increase. If your session is freed, right? Let's suppose generally what we have some pool of session ID on your Palo Alto Firewall. So it will allocate the session from this free pool. Once that session is terminated, or we can say closed, that particular session ID go back to the free pool, right? That particular thing is done by there is a one process running on your Palo Alto Firewall, free pool allocator, FPA. That process will run on your Palo Alto Firewall, and who will take care of these things, right? That time you will see this counter value will increase. If session is installed on the session table, this counter will increase, right? So this is how we have a counters for each and everything. Let's suppose you want to see if there is no route on your Palo Alto Firewall, and you want to see your packet is dropped by the drop due to the routing, you will see this counter value will increase. There is no route. Or let's suppose your packet is dropped by the security policies, we can see this counter value will increase, right? So the thing is, why I'm just bring these things in your notice, because see, in most of the problems, the first job of an engineer is to identify the problem. Basically, that problem is happening, why, or which is the component inside your Palo Alto Firewall is responsible for that particular problem, right? So this is the counter is the best, we can say, place where we can see the logs. Now how we can see the logs, don't worry, I will basically explain you in a detail, basically, okay? Because these counter will increase for each and every packets. But let's suppose, if I'll take example of data center firewalls, right? They will receive millions of packets, right? Now how we can create a count, create a filters for that, and we can take the help of these filters to view these counters. I will explain each and everything, guys. Okay, now let me just give you some brief about the counters first. So in Palo Alto Firewall, or we can say in your PAN-OS, counters are a very useful set of indicators for processes or packet flows or a session on the Palo Alto Firewall. We can use these counters for the troubleshooting of various scenarios basically. So which means we can troubleshoot different type of issues with the help of counters, guys. Just give me 1 minute. Yep. Now, if you want to, if you will run this command show counter global, you will get all the counter. If you want to see that all the counters, if you will run this command, let me just show you here. So counter, press the question mark, global, press the question mark again, type name and press the question mark. You will able to see these many counters if you will use all the features of your Palo Alto Firewall. More than 256 plus counters you will see, guys. We have a counters for, see, these are the different FPGA, right? You will have a counters for all of them. We have a counters for FPP unit as well, right? So you will get the counters for almost all the things. If you want to see the H related stuff, you will get these many counters for H related things. For packet processing, you will get these many counters, right? We have these counters, which means they have some value, right? That's why Palo Alto have added, right? Now, let me come back here again. So this is the command which will provide you all the process or actions taken on the packet, which is passing through the device. So whenever any packet pass your Palo Alto firewall, what your Palo Alto firewall will do, it will increase the counter. If your Palo Alto Firewall dropping the packet, it will increase the drop counter. If your Palo Alto Firewall allocating the session, it will increase the session counter that time. If any net is happening, then net counter will increase. If decryption is happening, then SSL decryption related counter will increase, right? These counters are for all the traffic and are useful in the troubleshooting of poor performance or a packet loss or a latency. So these kind of issues we can able to troubleshoot with the help of counters. There are severity levels associated with each counters. So these are the severity levels, guys. So if we will use the counter command with some filters, that time we will get some meaningful data, guys. So not an issue. I am gonna run these kind of commands only, guys, today. Okay, so let's take an example. Let me just give you what type of lab I'm using today. So because you will see I have a Palo Alto, then my test PC, I have a one EVNG machine as well. On EVNG, I have created one small topology here, right? So let me just explain you this topology part. And so you can have at least able to connect with the things properly, guys. Okay. So let me just clean here. Just make some space here. Let me just draw the topology, what type of lab topology I'm using. So when I will send that packet or traffic, you can able to connect it, right? So this is my Palo Alto firewall, guys. This Palo Alto firewall Ethernet 1x1 interface is connected with my home router. So I'm just putting here, this is my home router. Now this home router has a further connectivity with the internet cloud. Now this interface is my outside interface, and on this interface here I am having IP address which is 192.168.1.250. On my home route I am having IP address .1. So this is the default gateway. Now apart from this, I do have one more interface which is Ethernet 1x2. This interface is a part of inside zone where I have, we can say, one test machine. So what I will do here, let me just draw. I have put one router as well here. So this is the router. So router is inside R1. So let me just put here R1. Behind this R1 router, I have put one Windows machine as well on my EVNG. Now, here I am using 10.1.1.0/24 series, where on my firewall I have 250 IP address. On this router I have .100. On this region I'm using IP range of 10.1.2.0/24, where I have used here 100, and on this machine I'm using here 200. Apart from this, I'll do have one more PC here on the same range, 10.1.1.0/24 range. This is also my one of the test PC. That test PC having IP address 10.1.1.70. Apart from this, I'll do have one more interface here, Ethernet 1x3. Here I'm using 10.2.2.0/24 range, where on my Palo Alto I'm using 250 IP address, and here I have put one Linux server. I have one here Linux server. That Linux server having IP address 10.2.2.101. On this Linux server, I am running TCP/22, which is your SHS, and I'm also running TCP/80, which is your web server. So these services I am running. Right, this is my lab topology for your reference purpose. Okay, this is your internet cloud, you can say, and I'm getting the internet from here because on here also I have a here public IP, and I have one default out on my home Wi-Fi, and I'm getting the internet like that. So this is the lab topology which I'm gonna use today, guys. Now, let me do one thing. If I'll go here into my Palo Alto firewall, and if I'll show you these are the security policies I'm having. Let's suppose I'll go into this rule. Let me just delete this one. Let me just delete this host from here. Let me go on the ping as well, and let me just delete my internal Windows subnet details here. Okay, cool. Let me check the routing. What is the routing I'm having right now? So as per my knowledge, I just have one default route. That's it. I don't have anything, guys. Cool. Now let me just do the commit here. So now what I will do, so now let me just do one first task here, guys. What is the first task? If traffic drop by security policy, if traffic drop by the security policy, how you will troubleshoot? How to troubleshoot these kind of issues, guys, first. So this is the first task which I want to. In our case, guys, right now, as you know, we have just modified the security policy in your front only, right? So that's why I don't have any kind of rule. So which means if I don't have any rule, which means that traffic is dropped by these two rules, right? But let's see how generally how we will troubleshoot these issues with the help of counters easily. So let me just go here. So as you know, guys, when you will do the troubleshooting, what are the information we generally need from the, or what type of information we will ask from the customer? If you want to troubleshoot any issue, what are the information you will collect from the customer before starting the troubleshooting? So we will ask for the source IP address, right? We'll ask for the destination IP address. And apart from this, we will also ask the destination port. So let's suppose customer have provided that information. Source IP address he has provided 10.1.2.200. Destination IP, let's suppose he has provided 192.168.1.1, and your destination port, let's suppose, is 80. And what he's saying, he's just saying two things. When he's trying to open this particular portal from source IP address, which is 10.1.1.70, and when destination IP address is 192.168.1.1 and destination port is 80. When he's trying from this PC, he can able to open that portal. If he is able to open that portal, which means there is no problem with the portal, right? And when he's trying from this IP address, he is not able to do that, right? So let's see. So to troubleshoot these issues, guys, what you have to do? What is your approach for that? What I used to prefer, first thing, I will basically check my routing table. Always I will check the routing table. I have the routes or not. After checking the routing table, what I will find? I will find the zone details, guys, right? I will get the zone details for source and destination, and I will also get the interfaces, right? Behind which interfaces these two IPs are available. How we will generally find these information? If you go here, for that, generally we will use one command, which is test routing, have lookup, virtual router, then IP address. Then just select the IP. What is the destination IP address? Is 192.168.1.1. Hit enter. So actually I have to type here virtual router detail, I think, which is VR01. Then IP, hit enter. So when you will run this command, what you are getting? Your Palo Alto Firewall routing table is telling you this particular route available in your virtual router VR01. This is the destination. It is behind Ethernet 1x1 interface. And this is the IP address of that interface. Now, if you will run this command, so interface Ethernet 1x1, hit enter. By running this command, you will get the details of your zone. So this particular IP address is behind outside zone, right? So what we will get? We will get the some information here, right? Because see, when you will do these things in your production environment, it's become very hectic, because in production environment, they will have lots of interfaces and lots of zones, guys, right? So this IP is a part of Ethernet 1x1, and it is in outside zone, right? That's so we will get the some details regarding destination IP. Now let's see the details for source IP. Test routing, fib lookup, virtual router, VR0 IP, then 10.1.2.200. This is the another IP address, and you will see this IP address is also, it is showing towards this interface, Ethernet 1x1. Now this is wrong, guys, right? Because as per our topology, generally as per our network diagram, this IP address in your LAN zone, right? If it is in LAN zone, which means this particular route, if I run this console routing route, see, we have one default route, guys. So if we don't have any matching route for that time it will always take the default route, guys. So that's why this particular IP address, which is 10.1.2.200, is behind your outside interface, right? But in actual it is in inside interface. So let me just do one thing. Let me create one filter here, guys. So I will use the CLI here, debug, data plane, packet dex, set filter. In filter, what I will define the index number 1. What you want to define? I want to match Source address is 10.1.2.200. Destination address is 192.168.1.1. 1.1 and destination port is 80 and protocol number is 6 for TCP. Let's suppose they are connecting on the TCP port 6, right? Hit enter. We have created this. Now let me just enable it. Debug, data plane, packet dex, set filter, and you have to run this command on. Don't worry, I will explain these commands again, guys, okay? Because this filter I have to use with your counter, so you will get the result in proper way. I've created this filter right now. I'll go into this machine. This is my inside machine, guys, okay? I'll go into this browser. In this browser, I'll just go here and I'll just type 192.168.1.1. Hit enter. See, we are not able to open anything right now. If you will run this command, so counter global, you will get lots of counters, right? Is that information is useful because you are getting lots of counters are increasing, right? We are not getting the proper result. So that's why when we run these commands, if you will run this command with the filter option, filter, if you will type here delta, yes. Here, when you will run this command like that, you will get the changes on the counters always. What is the changes, guys, you have in your counters, right? So maybe there are lots of traffic who can also make changes in your counters, right? So this command is also not useful. But if you will go like that, if you will type here packet filter, yes, which means now it will give you the result for your specific source IP, destination IP, and your source port, whatever we have defined in your filter, which means this command will give you the exact result, right? Just run this command. Right now we have a 0 counters here. Now go here, not here, just go here, refresh it. Just refresh multiple times, run the command. Now, what it is saying, we have received the packet, right? Which means your receive counter is increasing, which means we are receiving the packet in your Palo Alto firewall. It is receiving your packet on the interface, but you will see this packet is dropped by the, if you will see, flow policy deny. The meaning of this counter is we don't have a security policy. We don't have security policy, and security policy is dropping this packet, guys. So now what we at least get some clue, right? We get one clue here. Your packet is dropped by the security policy. Now, if your traffic is dropped by the security policy, so now what do you have to do? Let me just go here. If I will add my security policies, I have this web traffic rule here. If I'll add here, this rule is towards from inside to DMG or inside towards outside. And these are the subnets. So let me add that subnet here. 10.1.2.0/24. I'm just adding this subnet manual. Destination is outside, application any, right? And we are just calling this service here, port 80. Click on OK. And let's do the commit now. Now just wait for this commit to complete. And after this commit, after that, when I will run that command, because right now, what will happen after that? See, we have resolved the policy related issue because we know this is the web traffic rule, right? So we have just allowed that IP address. Now, still, if you remember, still we are having routing issues, right? We don't have route for this particular network on our Palo Alto firewall. So why I want to Again, I want to show you, because see, routing related issue we can always identify with the test command, but we can also able to identify with the counter values, guys. So if you are having the connectivity related problems, always just create one filter, and after that just use the take the help of your counters. You will get to know this traffic deny by this thing. Okay, now just wait here. We will go one by one, and at the end, guys, I will also show you how you can take out the TCP stream from Palo Alto Firewall. Because see, this is the last result. This is the last option we generally use in the production environment. You can able to take out this kind of stream, how your TCP packet is handled by your Palo Alto Firewall, where it is dropped, because you will get the processing of your packet at each and every stage, right? And if somebody is new, if I'll explain you here, these are the stages we are having in your Palo Alto Firewall. And I'm just looking for diagram. Yeah, this is the diagram I'm having for Palo Alto. Packet flow. See, we have an ingress stage, then fast path, slow path, flow lookup, app ID, then we have a content ID. This is your content ID, then forwarding stage. Okay. So these are the stages we are having mainly on your Palo Alto Firewall. Okay, so let me see, commit is complete or not. So commit is completed. Cool. Now, this time if I'll go here, even though if I'll go here into this machine, if I'll refresh again, let me refresh multiple, still I'm not able to get the page. So right now what happening, your packet, right now your packet basically from this machine, it is reaching to your router, then router forwarding towards your firewall, and after that your firewall processing the packet, and it is forwarding towards the outside interface, and we are accessing web page of this router, guys. When this router is also sending the reply, but your Palo Alto Firewall dropping this reply because he is not able to find the route. What he is doing, he is sending back that packet here only with the help of default route, guys. If you will see, if I'll go here, if I run this command again, you will see we have received the packet, session is allocated, session is installed, flow policy deny, again it is increasing, NAT is also happening for that, but here you will not be able to see the routing related things. Why we are not able to see the routes problem here? Because we have the route, right? It is taking, it is sending the packet towards outside again. So what is the best way? If I'll go here, let me just remove that route as well, the default route. If I will remove the default route, which means I don't have any right route now. Let's see in that case how my Palo Alto Firewall will handle that particular packet. Just wait here. So meanwhile commit is going on, let me also tell you a few more things. So if you will run this command, so counter global, in filter you will get multiple options. You can filter on the basis of category, what type of packet you want to see the flow related packets or flow related counters, hit enter, you will get all the counters with regards to the flow receive for .1q tag, flow no interface, right? Flow policy no forward, flow policy deny, right? Then flow forwarding layer 3 multicast drop, flow forwarding layer 3 no route, right? No ARP, right? You will get all these counters. If you want to see, press the question mark. You have, like, if you want to see the packet related counters, you can run this command. Packet received, packet send, you will get all these counters here. Press the question mark here. If you want to see the session related packet, run this command. You will get all the packets. Like for session, session is allocated, freed, installed, discard, right? All session you will see here. Now, if you'll type proxy, and if you are using SSL decryption, you will get the proxy related information here. Okay. Now, so we have a multiple categories, right? If you will run this AHO, what is this AHO? Guys, anyone know what is this AHO algorithm in your Palo Alto Firewall? So no one is aware about that, guys. What is DFA here? Let me just give you a glimpse of these algorithm, guys. So if I'll go here, and this is the same data path, guys, which I have drawn. So just remember one thing. In your Jaguar chip, basically, this chip is responsible for app ID and content ID, right? Now, your app ID related task is basically done by the DFA algorithm. This DFA algorithm, it is running on top of your Jaguar chip. And this particular algorithm will do the application identification. And your content identification is done by the AHO algorithm in your Palo Alto Firewall. This AHO algorithm is running on your Jaguar chip. Let's take an example in your VM devices, virtual machines of your Palo Alto Firewall. They don't have these particular dedicated hardware engines, right? They just have a software based things, right? They are running on any of the hypervisor. So guys, these are the algorithm. They will basically help us on the app ID and content ID. That time they will run on top of your software basically. Okay. So these are the guys. This is how, guys, we will generally look for the counter related information. Now let me just again run this command. Now I have removed the route this time, right? If I'll go here into this machine, let me refresh multiple times. Let's see what result I will get. So I'll go here. Now let me refresh here one more time. Okay, cool. So counter global filter delta yes, packet filter yes. Now session allocated, session installed, flow IP, checksum validation, net dynamic port exit. So net is this time it is doing the net. Okay, but this time your packet is dropped by the routing engine, guys. So but we are not able to see any kind of counter for the routing, right? So if I run this command, so counter global name, press the question mark, you will get lots of counters here. Okay, so if I'll type here flow, even though, guys, flow, then let me press this forwarding, then L3, because I have a knowledge of these things. So you will see here, this time you will see this particular counter will increase, right? Packet drop due to no route, or packet drop due to no ARP, right? But this counter value is not increasing. No route. So guys, just remember one thing. You will see this is the value right now, 227, right? So what I can do, I'll go here. I'll refresh this multiple times. And if I'll increase, you will see the value is increasing to 52. But here you will not able to use the filter options, guys. Just remember. So if you run this command again, you will see this counter you are not able to get here, guys. Okay, so that's why I just wanted to tell you guys, for routing related problems, always use this test routing command. Always test the thing by running this test routing command, guys, and you will get the answer and you will get the details. Okay, because we don't have any route, so that's why we are not able to see anything. Okay, so test routing command is the best command for troubleshooting routing related problem. And if something is not working, let's suppose you are having problem with the policies and all, then you can use the global counter command. So just remember one thing. Now in your global counter, there is a one more thing I want to cover here. So counter global, go here, type filter. Now you can filter on the basis of expect as well. Basically you can select the expect, like forward, press the question mark, you will get the all the flow forwarding related logs here. You can use this command with the help of delta option as well. Then packet filter, yes. So like that also we can combine multiple things together, guys. What we will do, we can combine multiple things together. Let's see. Okay, and we can run the command. So these are the multiple options we have for running the counter command with the help of filter. We can define the severity level as well, right? Drop packet, drop severity. If you want, you can run the command. Here you will get all the drop related packets. Press the question mark here. If you want to see if there is any error, you can run this command, so you will get the error related packets here. Now let me just do one thing. Let me just configure everything. Okay, let me go here. Let me just add routes here. I'll add one default route, which is dr 0.0.0.0/0 towards next hop 192.168.1.1. Click OK. Let me add the route for my LAN subnet. So I'm just adding a 10.1.0.0/20, which will include everything. 10.1.0.0/20. 10.1.1.100. Click OK. Click OK. Let's do the commit and let's see the working scenario, guys. If everything is working, how we will see the things. Okay, and after that I will just jump into the capture part, how we can take the captures and how we can basically verify the things properly. Okay, so I will show you some working scenarios for that, and after that I will basically show you how you can take the TCP stream out of it. If you are able to extract the entire TCP stream, you can able to troubleshoot any issues on your Palo Alto firewall with regards to the connectivity. So it's 75% right now. Just wait here. $99. Succeeded. Now go here this time. If I'll try to open it, see I get the web page of my router, right? If I'll try to, even if I'll try to open, or I don't want to open as of now, so I will get the web page of this, right? I'll go here this time. If I run this command, show counter global filter delta, yes, packet filter, yes. Now let me just go here, let me refresh them. And you will see So guys, this is the working scenario. Right now, what's happening? How we will prove we don't have any issue with the firewall, right? Because sometimes we have to prove in front of customer there is that package dropped by the firewall not. So this is the best thing to prove. Basically, we can say we have received the packet and we are also sending that packet. Session is also allocated. Session event also install on the session table. Now, so your application processing is also happened. This packet has gone through with the app ID, guys. So we will get these things. It is also going through with your content inspection because you will see CTD PS scan. This is also another algorithm, right? So everything is working and this is the working scenario, guys. Now, what I can do, if I'll go into my whiteboard, now let's see one example here, guys. Okay, so make some space first. Let me clean this out. Okay, so guys, just see here. Let's suppose from the same PC, or let me go like this. Or let's take an example from this PC. Now, what I want to do, I want to communicate with this Linux server. So if I want to open, let's suppose this TCP port 80 means I want to open the web page of this server. So how that communication will happen, right? So let me just tell you this communication first, how they will communicate. Okay. So for that, if I'll just go like that, let me just draw a small diagram here. This is the test PC, right? Having IP address 10.1.2.200. We have one router. Then we have one firewall here. This is Palo Alto Firewall. And we have one server here, right? Let's have server having IP address 10.2.2.101. Here I'm using 10.1.2.0/24 range, and here I'm using 10.1.1.0/24 range. Now, here I'm using 10.2.2.0/24. This is my DMZ and this is my inside. Now, when I will communicate with this particular server, what will happen? How that communication will go through? First, we will try to understand that thing, and after that, I will prove that part. How you can prove that communication is happening in this way only. So, when on this PC we will access this server of web page of this server, we will basically send first packet through your Palo Alto firewall. That packet is your TCP SYN packet. Now your Palo Alto firewall received this packet, right? So how your Palo Alto firewall going to process this packet? So let me write here TCP SYN packet processing with your Palo Alto firewall. So what your Palo Alto firewall will do, it will first process at the ingress stage. Then it will, after that, it will process at your flow lookup. Then your slow path. Then fourth thing is your fast path. And fifth one is your egress or forwarding stage. Guys, can anyone tell me why this packet will not go through with the app ID and content ID? Anyone know why this packet will not go through the app ID and content ID? So guys, just remember, this packet will not go through the app ID and content ID because in TCP SYN, we don't have any type of application data. And your this TCP SYN packet is processed like that with the Palo Alto Firewall. And after processing this packet, if everything is fine, this packet will forward it towards the server side. Now, this server, what he will do, he will reply. He will reply with TCP SYN plus ACK message. Now, your file will receive this TCP SYN plus ACK message and it will also start processing this TCP SYN plus ACK. How it will do the processing? It will process at ingress level. This time it will do the flow lookup. Now guys, this time it will bypass the slow path. It will directly send that packet towards the fast path. Why it will bypass the slow path? Because session is already created. Okay. My firewall will create a session during the TCP SYN request only. And after that, your packet go towards the forwarding stage. Now, and your packet forwarded towards this PC. Now, this PC will forward the next packet. That packet is the third packet. So this is second and this is the third one. TCP acknowledgement packet, right? When my firewall receive the ACK packet, now firewall will start processing this ACK packet. How it will process this ACK packet? So let me just write down the TCP ACK processing as well. TCP ACK packet. So this is the first packet, this is your second, this is your third, and third packet is processed at your ingress stage, at your flow lookup, then your fast path, then your forwarding stage. And after that, this packet forwarded back towards the server. Now, from this server side, what we will get the, now you till here, your TCP session is established, right? TCP connection is in established state, right? And after that, this particular PC, he will send one more packet is known as, this is the fourth packet in our communication, which is HTTP GET request. Now your HTTP GET request received by the Palo Alto Firewall. Now how your HTTP GET request processed by the Palo Alto Firewall? So what it will process, let me write down here. Fourth packet is your HTTP GET. It is processed like that. Your ingress stays, then your flow lookup, then your fast path. Now guys, just remember this packet will go through your app ID, means now your Octeon chip will forward this packet towards the Jaguar chip for application identification. Now fifth one is your content ID and sixth one is your forwarding stage. So this is how your packet will be processed by your Palo Alto Firewall. And this is the exact processing, guys. And after that, your packet will go here. Now we will get the reply, right? Now, like that, you will see the communication is happening. So now what is our task here, guys? This is how they will do the communication. Now, what I want here, guys? I just want to tell you here how we can prove basically your send request is processed in this fashion. Your acknowledgement is processed in this fashion. Your TCP ACK is processed in this fashion. HTTP GET is processed in this way by your Palo Alto Firewall. How we can prove that? Right? So there are the multiple ways of proving that, guys. So what we can do, generally what we can, either we can use the packet capture So guys, with the help of this packet capture, we can see the in and out request on your captures. Now, if you want to see the firewall processing, we have to use the flow basic command. And guys, remember, when you are troubleshooting any issues on your Palo Alto firewall, always first create a filter and use the counters. This is the first thing which we will do. If you are not able to identify the problems with the help of filters and counters, then you can go with the packet capture. This is the second option. If your second option is also not helping you, then go with the last result, which is flow basic. Because see, when you will go with the flow basic, it's become very complex, and this is a resource intensive job in your Palo Alto firewall. If you have not created your filters properly, maybe your firewall will trigger, your firewall CPU will trigger. Okay, now let's see this processing, guys. So what I will do, let's just take the help of Wireshark capture first. So I'll go here into my Palo Alto firewall. If you want to configure the filtering and every like packet filter or packet captures on your Palo Alto, go to into monitor tab, packet capture, and you will get all the options here. You will get all options here. But what I will do, let me just show you the graphical way first, guys. And after that, I will show you the CLI way of it. So what you have to click on manage filter. And here now we will create the filter. What? We will put the index ID. If you want to define your ingress interface, as we know, our traffic is coming from Ethernet 1x2. What is the source is 10.1.2.200. I will define this value. Destination is 10.2.2.101, my DMZ server. Source port is any, destination port is 80. What is the protocol number? For TCP, protocol number is 6, so I will use here 6. I will exclude the non-IP traffic. This is the filter I have to just create. But this filter will capture all the packet which is initiated by 10.1.2.100 and going towards 10.2.2.101. It will not capture the packet which is coming on a reply. So for the reply packets, you have to create one more filter. Filter from 10.2.2.101, 10.1.2.100. Port number is 80. Sorry, guys. Protocol is 6 and exclude non-IP traffic. I have created this filter, guys. Now click on OK. Click on turn on the filter. So like that, we will turn on the filter. We have created the filter and we have turned on the filter, right? This is the graphical way of configuring these filters. If you go here, if you want to see the same information, if you run this command, debug data plane packet dex, guys, this is the command. Press the question mark here. Press the question mark and just run this command. So settings, you will get whatever we have created, we can able to see from the CLI. Right now, guys, I'm talking about this case. Traffic coming from initiated by 10.1.2.200 going towards 10.2.2.101, guys. Inside and DMZ. Okay. There is no net, nothing is happening. It's a direct connection. Now, and for your information, if you won't let me write down these interfaces as well, this is my Ethernet 1x3 interface. This is Ethernet 1x2 interface, guys. So I have created the correct filter, right? Traffic from this going towards this. Protocol is 6. Interface Ethernet 1x2. This is the ingress interface. And this is for the reply. Reply coming from this machine, going toward this one. Data ingress interface is this and protocol is 6, right? If you want to create the same information by a CLI, how you will do that? So what I will do, I will run this command debug data plane packet dex clear all. It will clear all the settings. If you want to clear only filter, run this command. It will clear the all filters. So you have to define, either you can define the values or either define this all. It will clear everything. Same thing, you can also able to do it from here. You can manually, if you want, you can delete the things manually. Clear session, clear all settings also you can able to do it. It will clear whatever we have done, everything. Now how we can do the same thing with the CLI? With the help of CLI, we have to run this command debug data plane packet dex. Press the question mark. What we have multiple things, right? We will use here set. Now what we want to set? We want to set the filters. I will use the filter here. Now what you can define, the index is 1. I mean, this is the number. Then match. If you want to see index, if you press the question mark, we are only allowed to configure 4 filters, guys. Just remember, we just have a number 1, 2, 3, and 4. Put here 1. Now match. Source is 10.1.2.200. Destination is 10.2.2.101. Destination port is 80. Ingress interface, you can define the interface if you want, because I know I can define it. Edit, define the another one. This is for Ethernet 1x3, and I will just swipe the values. 10.1.2.200, 10.2.2.101, and instead of destination port, I will define the source port this time. Source port 80, press the question mark. Now, do one thing, set filter, click on. We have created our filter, guys. So run this command debug data plane packet dex. So settings, we have created this filter, but why we are able to only see this one? Because I think I have used the same index number. I have used the same index number, so that was the reason I'm getting the wrong outputs, right? Let me just put here 2. So when you will configure these things, just make sure you are configuring correctly. We have not defined any protocol, so it has just taken the protocol number 0. So what we have to define the protocol number as well, guys. Protocol 6. Just add the protocol here 6. Now see the settings. Now we have the correct filters, guys. If you go here in your graphical, if you will refresh it, you will able to see these filters. Okay, so this is how we can create the filters with the help of CLI and with the help of graphical user interface. Now I will create a captures here. So I will enable the capture. So let me just enable later. Let me add the stages, guys. So in your Palo Alto firewall, we have 4 stages basically. These are the 4 packet capture stages: drop, firewall, receive, and transmit. So which means if your Palo Alto firewall dropping the packet, due to any reason, you will see some kind of packet they capture inside the drop, basically drop stage. If you are receiving the packet on your interface, you will see here into the receive. If something you have received the packet, now you have forwarded out from the egress interface, then you will see the packet on transmit. And the last one is for firewall. Here you will see the packet who is successfully processed by the Palo Alto firewall. If your Palo Alto firewall processing the packet successfully, you will able to see on this firewall stage. So these are the 4 stages you will get for packet capture. Now let me add here drop. So I will give the name here DP. You can define the packet count of bytes. I am going with the default values here. Add the another one, firewall, FW. Then you receive, which is I can give here RX. Now your TX, which is transmit. So I will give here TX. Click on OK. Enable the capture. Now we have enabled the captures, right? Now what I can do this time, if I'll go into that machine, let me just initiate the traffic. I'll go here. Let me just type 10.2.2.101. Let's see. Let me just see if my server is running properly. So right now I have not started the server. So let me start that server as well. Now, if you will go here, if you will refresh this thing, see we have seen the packet on drop and RX. Means that packet is dropped. We have seen that packet on the receive queue as well. So that server was not running, right? So what I can do, or if you go into your policies, maybe there is a one more reason. I'm not sure I have a security policy or not. So I have a DMG server access. Yep. This is also a reason right now you will see this packet is dropped by the policy. I don't have that particular subnet on my policy here, right? So if I'll go here, if I run this simple command, so counter global filter delta, yes, packet capture, packet filter, yes, go here. And if I'll go again, if I refresh this thing multiple times, I will not able to get it, but you will see packet is dropped by the policy, right? So now what I will do, let me just add that policy, that particular details of that subnet on my security policy here. I have to just call that subnet 10.1.2.0/24. Destination, these are the server IPs, guys, server 1, server 2, server 3. And I'm allowing for TCP 22 and TCP 80. Click on OK. And let's do the commit. So commit is about to complete. It's 99% right now. Now, guys, I will go on more in depth basically, because when we see the flow basic logs, I will tell you the techniques how we can basically club all the packets. Okay. Now, this time if I'll go here, I'll go to the web page, and if you go here into monitor tab, into packet capture, so you have seen I have captured the packet at DP and all, because these are the some old packet as well. Let me just delete them. Let me just go here into this machine again. Let me just refresh so I can capture one more time. So I have the packet on firewall, RX and TX, right? Which means I'm receiving the packet. I'm also transmitting the packet and my firewall is processing the packet. I don't have anything on the drop. Basically, drop means if you will see any packet on drop, which means your firewall dropping the packet, guys. So this is how we generally use to prove in front of customer. If you will see the packet inside this drop, which means your packet is dropped by the Palo Alto firewall. Now you have to further identify where it is dropped and why it is dropped, basically. Just remember. Now, if I'll open this firewall one, let me just open on my Wireshark here. See, that traffic is initiated by 10.1.2.200 towards 10.2.2.101. It's a SYN request. Then we have TCP SYN plus ACK. Then we have acknowledgement packet. And after that, we have HTTP GET request, right? Even though here you will get the entire page. If I'll open here, if I'll click on follow TCP stream or HTTP stream, you will get the web page details. See, we have seen this welcome to Skilled Inspirational Academy page, right? Let me close it now. So in case of TCP SYN, SYN plus ACK and ACK, guys. Now things are happening fine, right? This is how we generally captures the packet in your Palo Alto firewall, and we will later on we will analyze the packet. Now this is the working scenario, guys. Now let me just break this scenario. How I will break the scenario? Let me just do one thing. What I will do, I'll go here, I'll just delete all of them. I just go here and let me just disconnect this server. Means this server is not listening now. Let's suppose this server is not available. What result we will get in our captures, right? Let's see if server is not responding, right? This time if I'll go here, I'll refresh the page. See, it is not opening, right? If you will refresh here, you will see some packets. Still, we have seen forwarding stage, receive and transmit, guys. But if you will see one thing, if you will open this FW packets again, just open on your Wireshark capture. What you are seeing, we are just getting the SYN. We're getting the SYN from host 10.1.2.200, right? Towards 10.2.101. So guys, this is here we are just able to see the TCP SYN request, right? Which means I am sending the SYN request. But you will see after that I have a TCP retransmission, which means there is a multiple retransmission is happening, which means I'm not getting the reply from the server. And how you will prove that thing to the customer? Because by you can just show this particular capture, and also the best thing, you can show this capture, because see, you are sending the packet outside. Your packet is going out from your firewall. You can show this packet, and after that you will see some retransmission. It is doing the retransmission, but you are not getting any reply from the server, right? So this is how generally we will prove in front of customer we are not getting any kind of reply from the server. Now let me just do some more thing here, right? I close it. Let me just delete it. Let me stop the capture for a moment, guys, and let me just add few more filters here. I will add filter 3. This time what I want to add, I will add traffic from Ethernet 1/3 going towards going from 10.1.2.200. Let me just go with none here, guys. I will not select any interface. because generally if you don't know the interface, how you will check the things, right? So I will go with here none option. Now 10.1.2.200, let's suppose this traffic is going towards 192.168.1.250. Okay, now let's suppose source port any, destination port is, let's suppose 80, and same protocol is 6, and just exclude non-IP. Or here, this is the one, 192.168.1.1. Now guys, just remember one thing. Now I'm sending the packet towards outside, guys. Now traffic is going from inside to outside, means from my LAN zone to the WAN zone. And when any traffic go from inside to outside, that time just remember one thing. I have configured the port address translation. And according to my PAT rule, if I receive any traffic from inside any subnet, like I have put here this type of subnet there, that time just pat all these on 192.168.1.250, which means this is the case of net, guys. Now here is the one trick how you will create these particular filters if your traffic is going through the net, right? So let me just tell you one thing here. If I'll go back here, I will come back to this diagram again, guys, because I have to discuss few more things here. But before that, let me just tell you one thing. Now this is the case here. This is my firewall. This is firewall outside interface, Ethernet 1x1. This is my outside router, or we can say this is my home router or home Wi-Fi, having IP address 192.168.1.1. Here I am having IP address 192.168.1.250. Here I have another router. This is my inside R1. And behind this, I have this PC having IP address 10.1.2.200. Now, on this Palo Alto Firewall, I have configured the PAT, which is port address translation. Now, when I have configured the PAT, which means I've configured the PAT on my Ethernet 1x1 interface IP address. So, whenever any request which is initiated by this PC, which is going towards this home router or anywhere to in the internet, what will happen? Your PAT will apply, which means your 10.1.2.200 will be translated on 192.168.1.250, which means let's suppose this is the packet here. So this is the packet in your LAN, in your inside network, this one. If your packet is source IP is 10.1.2.200, destination IP address is 192.168.1.1. Source port any, let's choose here 1025, and destination port 80. Now, after the net, your packet become this. Your 10.1.2.200 will be translated on 192.168.1.250. This is the source IP, and your destination IP address is same, 192.168.1.1. This is your destination IP. Your source port same, or it will choose any random port, guys, because you know it will do the port randomization. And destination port is 80. So right now, if you will see here, your source port, source IP and source port is changing by the port address translation, right? Now, When this router, he has received this packet. So let me just write down here. This is the request packet, let's suppose. Now let me just draw here reply packet. How your reply packet will looks like here. When this router give the reply, right? So he will send the reply like this. So if I write down here reply packet, because this concept, if you don't know, you will not able to run the captures, so you will not able to create the filters properly, guys. So this time you will get the reply from 192.168.1.1. This become your source IP, and your destination IP is 192.168.1.250. This become your destination IP, and your source port become 80, and destination port become 3900. Now this is the packet our firewall will receive, right? When firewall receive the packet, it will again do the net. So it will apply the net like this. Your source IP, which is 192.168.1.1, it will keep same here. Now your destination IP 192.168.1.250, it will change with 10.1.2.200. And your source port, it will keep 80, and destination port, it will keep the 1025. This is source port. So it will do the packet like this. Now guys, when you want to write the captures, when we want to create the filter, right, for capturing the packet, what we have to do? For client to server means the traffic which is initiated by this guy, your firewall will it will start processing the packet according to these values, and when we will get the reply, it will process the packet according to this value. So what we have to do, we have to get these values here, right? In when your packet firewall receive the packet here, we have to put source IP address this, destination IP address is this, and your destination port is this. And when we want to create a now again filter for the incoming traffic, right? For that we have to get the value from here. Source IP we have to put this, and destination IP we have to put the net IP address, guys. Just remember, this is the clue here. We have to use netted IP address in that case. If you will use the netted IP address, so if I'll go here now, if I'll add the fourth one, source is 192.168.1.1. What is the destination IP I have to put here, guys? On which IP I will get the reply? I will get the reply on netted IP address, right? Because net is happening. So I will put here 192.168.1.250. And source port is 80. Protocol is 6 and exclude. Click on OK. Now start the captures, guys. Start the capture. Now do one thing. Go here to this machine and let's see. If I'll type 192.168.1.1, I'm getting the packets here, right? And I'm getting the login page as well. Even though this time, if you will remain, if you will open this capture, you will see all the packets. Just open it. Let me open on Wireshark. You will see we have a SYN plus ACK and ACK. After that, we have a HTTP GET request, right? So this is how we will create a captures, guys, or filters in when we are capturing the packet for directly connected networks, or when we are doing the captures for the net packet, if that packet is going through the net basically. Okay, now if I'll go here, let me just do one small change here. If I'll go here into static route, let me just delete the routing, guys, because I just observe one thing here. I have removed all the routes. Let me just do the commit. Okay, why we have not seen? I think we can also able to get the counters for routing issues. Okay, because previously we was have a wrong filter basically. So this is the way of creating these particular filter and captures and all, guys. And after that, I will also show you the CLI way of it, how we can create a captures by using CLI. And once we will done with that, I will basically explain you the flow basic, which is the most important thing. So I just need some more time, guys. It's 99%. Let's wait here. Cool. Now I'll go here. Let me just go into my topology first. And let me just start one capture on my Windows machine itself, basically. So I have just started the capture directly here. Let me go into my Palo Alto. Let me go into monitor. Let me just see. I have some old captures here, so let me just delete them. Let me close this, and we are just here. Go here. If this time, if I'll refresh this one, if I refresh this one as well, I will not able to get the page. You will see I'm getting the retransmission. Traffic coming from this machine going towards this host. I can see some retransmission is happening. Right? Even though if I'll go here, let me just try for this as well. So this also not happening, only the SYN packet, right? And after the retransmission. Why? Because this is the routing issue. We don't have any route, right? If I'll go here, if I run this console counter, global filter delta yes, then your packet filter yes. So this time you will see we are getting this counter value increase. Flow forward L2 no route basically. So this is how we can basically see the routing related issues as well. Previously, I have not created the filter properly, guys. So that's why that was the reason we were not able to see it properly. But this time we will able to. So you will get this counter value will increase if you don't have any route. So this is the one way also to basically troubleshoot the routing related problems. Okay, so we have seen problem with the routing. We can able to T-suit with the help of global counters. We can also troubleshoot the security policy denied related problems as well with the help of counters, guys, right? Captures we will generally use to validate the entire TCP stream. Basically, it is working or not. Okay, now if you will see, I can take the capture and I will also able to see the same type of captures here, whatever I'm running here. Okay, so I don't want to show you here. Now, let me just delete them. Let me delete all these capture stages as well. Okay, now I'll go here. Let me add these routes back, and after that I will show you how we can configure the packet capture with the help of CLI, guys. So I'm just adding my route back here. 10.1.2.0. Tender 1.1.100. Just wait for this commit to complete. Meanwhile, let me just show you how we can basically configure the filters and captures with the help of CLI. Debug, you have to use the same command. Debug data plane, packet dex, clear. Let me just clear all the settings. Now let me just start from here. So first I will show you how we can create the filters like we did last time. Packet dex set filter index 1. Define the details here. Define the source IP address is 10.1.2.200. Destination IP address is 10.2.2.101. Destination port is 80. And your protocol is 6. So we are just capturing the TCP packets. Now I will use the same command. I will use index number 2. And I have to just do the vice versa, right? So I'll just put these values in a reverse way. Protocol 6 and source port is 80. So I can capture the reply packet as well. Now this is how I will create the filter. Now I want to turn on this filter. So I will use the same command, debug data plane packet X set filter on. So it will turn on the filter. Now you can always use this command to see whatever the configuration you have done, it is correct or not. Now let's try to configure the packet capture. So you have to run this command, debug data plane packet dex set packet capture or set capture. What? You will have a multiple options here. So we have to define first stages, guys. What are the stages? So here you will get in CLI, you will get 2 more stages for clientless VPN and clientless VPN server. I will go with drop, then file name. I will give dp.pcap, hit enter. Now stage is firewall, file name fw.pcap. Why I'm getting this pcap basically? So if I want to export these particular captures file from CLI to any of your system, I can able to do that by using SCP protocol or TFTP protocol. Now stage firewall, and after we have transmit, file name is tx.pcap, and we have last step which is receive, file name is rx.pcap. And at the end we have to turn on the capture. Set capture, press question mark. What? I want to turn on the captures. If you want to see these options, you can also capture the packet for a specific username for the clientless VPN, guys. I have covered these things on my VPN classes. Now if you want to verify all the things, you can run the same command, show settings on the CLI. You will be able to see this is the filter I'm having. This is the capture I am having, guys. Right now I have not captured any of the packets because you will see counters is 0 here, right? Packets 0. Now go here. If you will see the information on the monitor tab, you can able to get it from here as well. Whatever I will configure on CLI, you can get it from the GUI as well. Now, if this time I'll go here, if I'll try to open, why I'm not able to open, guys? Because that server is not running. I have disconnected, right? So let me just connect it. As soon as I will connect, if I'll refresh, I will get the page here. Now, if you want to see you have captured something or not, run this command right now. See, we have captured 28 packets on your receive stage. We have captured 28 packets on your firewall stage. We have captured 20 packets on your transmit state, and drop is 0, which means 0 packet we have captured at the drop stage. If you will see this number is same, which means everything is working fine. If these numbers are same, guys, in your firewall stage or transmit stage, these numbers are same, which means everything is fine. So this is how we will basically configure the packet capture in your Palo Alto firewall. Now, if you want, you can also run this view pcap command, but this command debug pcap. So here you can only able to see the IC manager related pcap because these are the packet capture I have run previously. Then filter pcap, and you can able to see the pcaps here as well. Hit enter. So if you want to see them on the CLI, you can able to do that. But the best way, always refresh here, download into your local system and view it. That's the best way of it. Download it and just start watching here. Okay. Now guys, let me quickly show you the last practical of today. So this is how we can basically use all these values. The last resort for all the troubleshooting is your flow basic, guys. Okay, for that I will not take much time. I just need around, see, you can able to view it like that if you want from here. Now guys, let me also go through with the flow basic. Okay, so I will go through with the flow basic, and I will try to take out this TCP stream, how we can do that. Okay, so it will not take much time because see, my filter is there, so I just need a filter. I do not need captures if I'm running flow basic, guys, but if you want, you can keep them as well. I don't have any issues. Okay, now go here into the CLI. I will run this command debug data plane packet dex set. Press the question mark, type your log, because this option you will not get on the CLI, guys, on the graphical user interface. These are the advanced debug commands. Okay, and these commands you will not able to see on the graphical user interface. Okay, this flow basic, you have to go it from here, log, then you have to select feature. What I want to just capture a flow, because you can capture app ID, base, CTD, flow, right? You can capture lots of packets, but I will just want to capture flow. What I want to capture all the things on flow, like R, your net related things, your H related information, your log related information, receive, SD-WAN, everything. I just want to capture the basic thing only. Debug data plane packet deck set log feature flow basic. Enter. Now just turn on the flow basic. Just click on and see the settings. So settings all. or show settings. Right now you will see we have enabled the logging, which is enabled yes, and we are running at the basic mode only. Basic mode is more than enough, guys. Okay. Debug. After this, what do you have to do? You have to go to into your machine. Just access this server. Run once only. Go here. See the capture. We have captured the packet. Turn off the capture. Turn off the filter, and turn off your log basic. Always turn off this logging basically. Do not keeps running them. Now you have to run one more command, debug data plane packet dex aggregate log. This command you have to run it. I will tell you why you have to run it. So we have got this file now. Now what you can do, what I will do here, I will open my same Palo Alto firewall in new tab, guys. Otherwise, because I will get lots of blocks otherwise. Okay. And I will run here this command less mp log, and I will put this file name. You will see I can able to see lots of packets here, right? Now from these packets, we have to basically see we have received the packet and all, right? Now from this stream, we have to take out the TCP stream from these packets. Basically, how we can do it. This is the main task, guys, for today. So what I can do, let me go on top here, and I will just copy all of them on my notepad plus, and I will basically tell you the logic how you can take out this particular TCP streams. I just need around 15 minutes more. That's it. There are lots of other information I wanted to cover, because due to the time limitation, I will not able to do that today. Let me go at the end. Let me open my notepad. Control V. Okay, so I have all the logs here, guys. Okay, now how we can, if you know the TCP three-way handshake properly, if I'll go back here, that's why I have explained this part here, guys. In this TCP three-way handshake, right? If you remember here, in the first packet, what we have? We have some kind of sequence number. We will get some value for sequence number, right? Let's suppose we have here value is 100. What is the value for acknowledgement number for TCP SYN packet? Is 0, right? Now when we receive a SYN plus ACK packet from the server, so that time you will get some sequence number from server 2 as well. Let's suppose we have get the 200, and what is the acknowledgement number that time? Acknowledgement number is 101, right? Now in the third packet, what will happen? We will send the sequence number is 101, and your acknowledgement number is 201, right? So I will just use the logic of the sequence number and acknowledgement number onto this particular stream. What I will do, if I want to find out the first packet, I'll just type here, I will just find with ACK equals to 0. And I'll got the first packet, guys. What? I'll got the first packet here. This first packet I have received at the ingress stage, because this packet have the acknowledgement number 0. And after that, I will highlight the sequence number. So I have received this packet at the ingress. So let me just copy this value and let me just tell you the processing of it. Go here. Let me just put it here. Now, what? We have received the packet at the ingress stage. This is the length of your packet, which is 66 byte. Forget about these are the some internal bindings of your interface in your PAN-OS. Sources coming from 10.1.2.200 going towards 10.2.101, right? This is your layer 2 information, then layer 3, then your layer 4 information. Then we have a TCP options field, and right now, guys, there is a no active flow found, right? Because it was a first packet, which means now this packet will go through your slow path. So it is going towards the slow path. And if you highlight the sequence number, you will get this is the right packet you are looking. It has created the session in your slow path. It has done your routing, your net, your policy lookup, all these things. And after that, it will go into your fast path. And after that, your packet is transmitted out from the outside interface. Now, so this is how we will basically get the first packet, which is your TCP SYN packet. This is the TCP SYN packet I have basically get from the Palo Alto Firewall. TCP SYN packet. Your firewall has processed your TCP SYN request. If there is any issue, guys, in your Palo Alto Firewall, if your packet is dropped at the ingress level, you will see your packet is dropping here. If your packet is dropped by the policy, you will see your packet dropped by the policy is here. Which rule is matching? You will get the rule details as well. If your routing is dropping the packet, you will get the details here. Here, because here we are getting the actual processing of your packets, guys. Okay. Then this is how we will take out the TCP stream. Now, if you want to see TCP SYN plus ACK packet, what you will do? In TCP SYN plus ACK packet, you can go here, take this value, copy this value, and just find out here, type here ACK, put the value and increase 1 here. Instead of 28, just put 29. This is your TCP SYN plus ACK. How you can? This is the TCP SYN plus ACK packet. So, but this TCP SYN plus ACK, it has received at the ingress stage, then it is directly going towards the fast path, guys. And this is what I have said. If you will see here, what I said, ingress, flow lookup, slow path, and fast path. And after that, it has go into ingress, flow lookup, and fast path, right? No slow path here. And you will see here, we have found the active flow in your session table. So it is directly going towards the fast path. And this is the packet, guys, for your fast path. Then your egress stage. Now copy. If you want to see the next packet, what you will do? TCP ACK. Let's suppose you want to see this packet. What you can do? Go here. See, in this packet, if you will go here, if you highlight the acknowledgement, right? Because we have sent the ACK for this, which means from the host machine, we will get the sequence number value, which is this one, right? So highlight this, you will get the next packet. Sequence number is this. This is your acknowledgement packet. So we just take the help of the sequence number and acknowledgement number, guys, and we will able to get the details. We can able to get the entire detail. This is your TCP ACK packet. This is going quite fast, guys, due to time. But now if you want to see HTTP GET message, how you will get it? It's very easy. Go here, go into this, go here. Highlight this acknowledgement number or highlight the sequence number. This is the HTTP GET packet basically. And this is your CNET's web page. Basically, they have stored into these memory locations. This is the HTTP GET request basically. These are the memory address of your Palo Alto firewall where we have stored your packet. This is the next packet after that. So that's how basically we will troubleshoot the Palo Alto firewall related issues with the help of global counters, packet filter and packet captures and flow basic, guys. This is what I want to cover in this particular class, guys. Now I'm just stopping the recording.